Hey everyone, welcome to our YouTube channel. This video will give you a geometric intuition about linear regression. So let's learn what is linear regression using a case study. All right. So it says you have been given 10,000 employee informations such as years of experience and their salary. Based on the data given, you have to predict the salary component of other employees given their years of experience. How should you proceed? So what it says is, let's go to the whiteboard. Basically, let's say in a Excel sheet or any other spreadsheet, you have been given information about years of experience. So let's take years of experience and the salary. So let's say the salary is lakhs per annum. So let's say someone with 0 years of experience is getting somewhere around 5 lakhs per annum. Someone with, let's say, 2 years of experience is getting around uh, 8 lakhs per annum. Someone with 5 years of experience is getting somewhere around 15 lakhs per annum. And someone with 7 years of experience is getting around 21 lakhs per annum. Okay. Now, the question to you is based on this data, you have to predict the salary component of other employees with some different years of experience. So, this data that was given to you consists of that of 10,000 employees. So, 10,000 data points. All right. And suddenly, let's say the question given to you is, so now predict what should be the salary given someone has around 15 years of experience. How do you proceed? That is the given question. Just pause the video and try to come up with some sort of a logic. All right, great that you have tried. Now, one thing can be, we can simply say, okay, fine, for 7 years of experience, we are getting 21. So for 15 years of experience, which is roughly twice the years of experience, we should get twice the salary. That is 21 into 2, which gives me 42. So it should be 42 LPA. But is this method very correct? Not really. So for 2 years of experience, someone is getting 8 LPA. Then for 4 years of experience, someone should have got 16 LPA, which is not the case over here, right? Again, 5 into 3 that is 15. So ideally it should have been 45. Again, 7 into 2 is around, 14. So somewhat less than 15, but it's getting 42. So there are certain discrepancies, correct? We cannot simply say just by seeing, let's multiply with a factor of the year of experience. So what can be other approaches? Another thing that we can do is probably we can plot a scatter plot with the data. So what we can ideally do over here is, okay, let me take some dark color. Okay, so let's say with this given data, right, I take a scatter plot with, let's assume, salary in the y-axis and years of experience in the x-axis. All right. So for 0 years of experience, someone is getting 5 LPA. This is the point. For 2 years of experience, someone is getting 8 LPA. For 5 years of experience, someone is getting 15 LPA. And for 7 years of experience, someone is getting 21 LPA. Great. The question is, what is the salary when the years of experience is 15? So what we can ideally do over here is, now we know, okay, this is how the graph looks like. Can I not join these lines, right? And maybe extrapolate it. Okay, so graph was not very good. Let me just erase this and create another graph. Okay, so what I tried to tell you is, let's say there are some random points, right? These are the points. So can I not say if I join these lines and I want to predict what is the salary, this value for this given point, I'll simply extrapolate my line, right? Simply extrapolate the line. And for the given x, that is this value, which is 15 over here, what is my corresponding y value, right? So this value that you see over here should come as a salary, isn't it? Does that make sense? So this is, let's say, for 2 years, I'm getting a salary of 8. For 5 years, I'm getting a salary of 15. This is 15, let's say. And this is, let's say, for 7 years, I'm getting a salary of 21, right? So what should be my salary when the year is 15? I simply extrapolated this line and found the intersection point for x-axis. What is the corresponding y value, which came out to be, let's say, 50. So I now know, okay, fine. For 15 years of experience, I'm getting 50 LPA as the salary, right? If you feel this is a very good way of prediction, this is all about linear regression. This is the geometric intuition about linear regression. All right. So let's come to what linear regression actually is. So that is exactly what has been given as the solution. We first plot a scatter plot to understand the distribution. That's exactly what we did over here. Scatter plot to understand the distribution. Here, the distribution was very linear. Not always do we get linear values. Sometimes what happens is the points are very scattered, right? And you need to find out the best fit line. So sometimes you have to find the best fit line. And how to find the best fit line? We'll come to it in a moment, right? We have to find the line that is the best fit line. And now we do whatever we want to do, what we have learned. Okay, next, based on the data points, we plot a best fit line. By extrapolating this line, we can predict the employee salaries based on their years of experience. So this is step one. We plot the data points, which is fairly linear in nature. This is point two, that is based on the data points, we plot the best fit line. And this is what linear regression actually does. So the model linear regression is responsible for creating this best fit line. All right. So I hope now you have a good idea about what linear regression actually is. Now the biggest question now lies is, what is this best fit line and how to find this best fit line, right? How do I say this is my best fit line? Okay. So the idea behind regression is how efficient this line of fit can be and how much error we can reduce while doing this. Okay. So what is linear regression? A linear regression is a statistical technique used to model the relationship between a dependent variable, that is the target. Here, the salary is the dependent variable. The salary depends on the years of experience. So the target that we want to find is the salary, right? So a linear regression is a statistical technique used to model the relationship between the target, the dependent variable, here salary, and one or more independent variables. Here we only have one independent variable, which is the years of experience. So linear regression is what? It's nothing but a relation between the target variable, that is salary over here, and the independent variable or the features here, which is years of experience, right? It is simply a straight line. And I believe we all know what is the equation of a straight line. It's nothing but y equals to mx plus c, right? Y equals to mx plus c. In certain other places, you might also see something like y equals to beta naught plus beta 1 into x. So here beta naught refers to c and m refers to, beta 1 refers to m. Now, what is this m or c or beta naught or beta 1? All right, let's come to here as well. Now, y, as we know, is the output variable here, the salary. So all the points you see over this line are points belonging to y. All these points refer to the salary, right? The dependent variable. So all these points over here, this line, are my y. Okay. Now what is x? X is nothing but the independent variables. variable or variables. In our case, we are choosing only one independent variable, which is the years of experience. So y here becomes our salary, that is the output or the target. X here is the years of experience, which is our input or the feature. What is M? M is the slope. So what is the slope? If we simply extrapolate this line to the origin, the angle that it makes with the origin, right? Theta, let's call it. So tan of theta equals to M. This is what our slope is, tan theta. So M is the slope and C is the intercept. So this position, right? This position where the straight line cuts the y-axis is what we call as the intercept. All right. So C is our intercept. All right. So these are the different terminologies in linear regression. Y is the output or the target, X is the input or the feature, M is the slope, and C is the intercept. Now, how to understand this in a much more non-technical way? For example, let's say I want to predict the, uh, let's say, salary, fine, given a year of experience. So I say Y equals to, let me just change the color of the ink. So I simply say Y equals to M. I'm giving a weight to it into X, that is M into years of experience. So give this much M times weight to years of experience. Let's say I'm giving a weight of 1.25. So as your years of experience increases, your salary should increase by 1.25 times. Plus C. C over here is the base salary. So even if your years of experience is zero, right? Even if your years of experience is zero, you should get some sort of a salary. Here we took an example of, I believe, 3 LP or something, right? So now I hope you also understand it in a non-technical way as well. C here refers to the salary that you get without any years of experience. That is the base salary. And with every increment in your years of experience, your salary also increases by 1.25 times. The base remains the same, but your salary increases by 1.25 times. So this, my friend, is your linear regression line, right? And I hope this is absolutely clear, right? So this was all about the geometric intuition of linear regression. Next, we'll understand how to create a linear regression model from scratch. So see you in the next lecture. Thank you.